Hello, everyone. Welcome to the stream. My name is Kat, and I will be your host today. Three super quick things before we start. First, for those who are watching us online, be sure to comment in the live chat and ask your questions there. At the end of the talk, we will definitely answer all your questions, or at least the ones that we will manage in the time. Second, please be nice to each other and us in the comments and in the live chat. It's very important for us to be respectful. And the third one, please help me welcome with the round of emoji applause our awesome speaker buddies.
Hi, Kat. Thank you for your
The stage is yours.
introduction. Thank you. Hi, everyone. My name is Boris. I'm a software engineer at kiwi.com. And today I will talk about how to effectively test web applications. First of all, why would we want to test? Every software has a specification, right? Software is something that solves problems. Specification is something that tells us what problems our software solves. For example, this to-do application, we can add to-dos, we can edit to-dos, delete to-dos, filter to-dos by their completeness, etc. Every business requirement is a part of the specification. This includes any user stories, tracking events, security, accessibility, the way our application works. The main point is, how do we ensure our application works over time? And to do that, we make our specification executable. We write tests so that we can execute our specification to ensure that our application works. This is the meat and potatoes of software quality. We want software quality to be able to iterate quickly. We want software quality to have speed of delivery. For example, with this flow that uses manual regression testing, the engineer works on a feature. Then after chunk of the work is done, they hand it over to QA to do manual regression testing. There's some bugs found, so it's returned to the engineer, fixes that. It works some more on the feature, maybe fixes some bugs along the way that the QA team has found, until the release. After the release, they may be a regression because manual testing, doesn't really, it's not complete, can be not complete. You have to revert, do another round of QA after the bug is fixed, release again, etc. This is very inefficient. The engineer has to wait and context switch often. QA person has to retest the same thing, same application over and over manually. Fixing broken production can be very expensive. And this all is compounded by the fact that there's an opportunity cost in undone features or undone improvements, because we are doing all this labor just to get one thing into production. Compared to a flow where we do have an executable specification for our application, the engineer picks up work, works on the feature, cooperates with a QA person to write good executable specification for our feature, improves the feature by getting feedback from the QA person. And once the feature is in production, all is fine. We tested it and we can move on to other things. This way, engineer and QA time is fully utilized. It's efficient. We have automated regression testing and zero production incidents. And in the process, we build a better and more robust feature. Now, to get quality software, we need to be able to iterate on it quickly. As Malte Ubel, the CTO of Vercel, said, iteration velocity is the solution to all software problems. The thing is that with our tests, there's a point where if we test beyond our system specification, the regression prevention doesn't go up anymore. It just stays level, because if we already have tests that fully check our software specification, we know it works. There's no benefit in going into even more detail into testing implementation details. And the efficiency and speed of change goes down. It's expensive to write a lot of detailed tests, to maintain a lot of detailed tests, and you do a change, and suddenly that, it wouldn't break anything, but because you're testing your specification, suddenly you have to fix 36 unrelated unit tests just because of some small change somewhere. And it gets really tedious having to, either adjust those tests, or delete them, write new ones. It's convoluted. This slowness of change leads to the inability to adapt to new situations, new requirements. We are not interested in some arbitrary metrics here. We're not interested if every file has a related test file. There's no point in obsessing over coverage. What we care about is whether our application works, and we test that with our executable specification. We test our specification. If it passes, it's go time. We can go to production. Speed enables us to adapt to business needs. Economy changes all the time. There's competition. Features need to be delivered. New technologies pop up. If you're able to deliver new things, to adapt existing things quickly to what your business needs, you get an edge over your competition. And to sum this all up, here's a little rhyme. Test too little, system becomes brittle. Test too much, changes out of touch. Okay, that's quite enough on why we want to test. Now let's talk about how to write a solid executable specification. Ask yourself this: how do I best ensure my application works? First of all, you of course want to verify that your application works for your users, that it's usable, it's pleasant to use. And second, you want to check that your app also fulfills all of its business requirements. And to do this, a very good strategy is to go top down, where you start with high-level UI tests. These are performed from the perspective of the user, and they test user stories. They check whether events are tracked correctly, whether the application looks like it should on various devices and themes. It's accessible, navigation of the application works, and forms can be submitted. High-level things like this. These are coarse, broad tests. And if all these pass, it's already a very good, display of the overall quality of our software. We then move down to component tests. The point of component tests is to check usability of components and also technical details, whether interactions with your components causes the desired effects. Before, we were only interested in user interactions. Now it's also interactions with the API of the component. We want to check how components look and whether they're accessible as well. Lastly, the most granular tests, unit tests, are for checking any potential edge cases in our business logic and check that our algorithms do what they're supposed to be doing. Okay, first, let's talk about UI tests. Behavior-driven development did a very good job in bringing us a framework how to write or design our UI tests from the perspective of any audience that you want to check. In our case, it's going to be a user, and we can write a narrative to adding a to-do as a user, and it would be, as a user, I want to add a to-do so that I can keep a track of to-dos. We can map this narrative to a test where first we import a fixture that represents a user. We describe the action that the user wants to perform. And then we define scenarios, different scenarios that can happen when a user performs this action. For each scenario, we then define acceptance criteria. For example, illustrating the happy path, given I typed in my to-do, when I submit the form, then the input field is cleared and the to-do is added to the list of to-dos. And the test is very much similar structurally to this human description of the scenario. We first select the to-do field, text field, where we add to-dos. We fill in do stuff, as an example to-do. We simulate a pressing of the enter button, and then we assert that the field has been cleared and that the to-do was added to our list of to-dos with the text that we specified. One important thing with UI tests is that they should obey system boundaries. If your software is communicating with APIs, services that can come from teams in your organization or third-party services, you want to isolate yourself from these and mock calls to these services so that your tests are isolated. This also allows you to simulate responses for example, errors like unauthenticated and various different things that could happen. And if you own your data, you work with your own database, there's a huge benefit in that you can perform these tests end-to-end, right? You can set up your database and run your UI tests end-to-end against your database. Integration tests look something like this. Before each test, you set up your mocks, where you mock your API route with a certain response, and then you run your test in an integration manner. End-to-end can look like this. For example, you can set up your database however you need, add some entries into the database, and then you run an end-to-end flow. This really gives you a very good confidence that your system as a whole works. So if you own your data, use this. It's really great. All right, we have checked whether our application works. Thing is that if you just slap HTML without any styling on your page and run these tests, they would probably work. We also need to check whether your application looks right. And that is done using screenshot tests. You set up various scenarios. For example, in this case, for example, we have some to-dos in the list and no to-dos. And you take screenshots, which you then compare to changed screenshots later on when you perform some changes. It's done in a simple, straightforward way. You set up your state, any combination of states that you may have. In our example, it was some to-dos, no to-dos. And for every page, you want to take a snapshot of the layout of every segment. Note here, we are not interested in every single possible state of each component. We are only interested in the overall application layout now. One downside of screenshot tests is that they do break very often. Because you're screenshotting such a huge chunk of your application, any little change will cause your screenshots to be different and thus break the pipeline. They're, however, very easily updated. You essentially just have to run your test command and say it to update snapshots, and you're done. During code review, you verify whether this is okay, this was intentional. If yes, you go ahead with the changes. Accessibility is done in a similar manner. You set up your page, every state that you're interested in, and check each segment for violations. If there's some contrast violation or a missing label, these tools will let you know. So this is essentially how it's done. You set up your state, check whether the page is accessible. Straightforward. Keep it really simple. Like this simple setup will cover most of what you need, because it's computers. They're very good at checking these very little details of contrast and labels missing and things like that. For more in-depth audit of accessibility, you can occasionally perform a manual QA round that will give you a better overall picture of how accessible your page is to real-life users. All right, this was quite a bit of tests written. Do we even need more? We do. The reason is we covered a big chunks of functionality, but there's still possibilities of edge cases that we didn't cover. And the next section will focus on covering these for components. Main purpose, as I mentioned before, is covering component usability. Whereas UI tests are done from the perspective of the user and check and simulate user behavior and check how the application performs for the user, component tests are done for engineers so that engineers know how the component behaves, that it fires the correct callbacks, and that all possible interactions work as expected. An example component test can look something like this. We take the to-do form, the one which already has a to-do, in the list. First, we select the input element and we simulate a double click on it. And we expect that the input received focus and also that the on-change editing callback was fired with the value true. Regarding screenshots, the flow is that you want your component in every possible state. In the example on the right, we take a button, render all types of this button, and for each type of this button, we simulate, well, we don't simulate anything, take a screenshot, and we simulate hover, focus, and active states as well, and check whether these look as intended to. Same applies for accessibility. Get the component to every state you're interested in, check for accessibility violations. Most often this will be contrast, and that's it. Regarding simple components, it's usually completely fine to only test screenshots and accessibility. Most of the control flow in your component will show up in screenshot tests. In the example on the right, there's the loading state that changes how the component looks. And if we render the button in a loading state, we automatically check whether the loading state looks like it should. And we can rely on the component working because all we do is pass props to a native React component. And come on, like, you can rely that the React component works. If there was really something critical, like props wouldn't be passed to the native component, this would show up on UI tests anyway. Like, you wouldn't release broken software to production. Yes, it would be code hired up, but it would be pretty obvious that your buttons don't work. So it's just okay to test only for screenshot and accessibility for like these simple components. Regarding more complex components, you want to simulate user interactions, how the user would use this component, and check whether the component behaves correctly also from the engineer's perspective, like we mentioned. Callbacks, things like that. You want to do screenshot and accessibility testing too. And what I recommend is to avoid over-testing subcomponents. If you have components that are private to your bigger component, for example, this date picker is a really big component and it has a lot of private components, testing this big component as a whole is enough to verify that its subcomponents work correctly too. Remember, we are testing specification. We are building an executable specification. We want to avoid over-testing implementation detail as much as possible so that we facilitate change. All right, to sum up component tests, test user interactions, check whether callbacks are fired with the correct values, whether user interactions cause the desired effects, take screenshots, check accessibility, and remember, guys, it's about executable specification. Avoid testing HTML elements, asserting HTML structure, for CSS rules, or any internal state. Like, this is implementation detail. We don't care about that. If the component specification works, that's completely sufficient. Now onto unit tests, the most granular part of our executable specification. Here we focus on algorithms and business logic, cover the tiniest possible leakages that we could have in our executable specification. This can range from low-level things like mathematical operations, byte streams, string date manipulation, even state machines, up to whole business flows, schema validation, database and file system manipulation, interface interactions. I can't stress this enough. Remember to only test the specification. If you have a piece of business logic, like function that saves something to a database and has a bunch of validations and possible control flows, if it's feasible to test that thing as a whole, even with the SQL query it may have, or a bunch of them, you want to test the thing in its entirety. You have a robust test suite that verifies that the thing works, and at the same time, you're open to change its implementation to your will. As long as it obeys its contract, its specification, it's okay. If it becomes unfeasible to test, the test would be just too long, or it would be awkward, difficult, whatever, go finer. By all means, split it so you test its pieces, and then you test that it's composed together, but only if necessary. One example from our to-do app could be this mutation that adds a to-do. First of all, we check schema. We supply a bunch of invalid form values and make sure that this mutation rejects those values. And at the end, we check the happy path. We supply correct values and assert that the to-do was added to the list of to-dos. So for unit tests, write your functions as pure as possible. These are very easy to test. Create interfaces for libraries that you cannot call directly in unit tests. You just put them behind an interface. Don't mock these. Put them behind an interface and check that interfaces are interacted with as you want them to. Intercept service calls the same way you do in UI tests. You want to check whether service calls were performed correctly, and you simulate a whole bunch of responses that could potentially happen. And if you own your data, set up / tear down the database per test as you need. This also makes you test your SQL queries, which is huge. You could. It's very easy to mess up a SQL query. You want those tested as well. And you definitely want to avoid premature granularity. As I said, it's about testing the specification. It's executable specification. It's not executable implementation, right? Keep your test as high as possible. Avoid mocks. Just don't mock if at all, if it's possible. The only good time when to mock is when it's at system boundaries, right? Like you don't want to interact with other services. You want your test isolated. For anything practical, just put it behind an interface and test interface interactions. And of course, you want to avoid any kind of non-determinism. You want your tests to be consistent. Okay, last section, manual tests. We have our executable specification. Why the hell would we want manual testing? Well, the thing is that computers are fast. They're very good at performing repetitive tasks quickly. This is awesome for regression testing. However, what computers don't yet have is the ability to think and feel. And humans do that. So humans are very good at assessing user experience, telling you whether your app sucks or not. Computers tell you whether it works or not. So manual testing, manual QA testing is awesome for exploring product opportunities. QA people can cooperate with product people to find new opportunities, how to improve the product they already have, or how to, what new features to introduce to make it even better. And QAs can collaborate with developers when creating new executable specification for new features. The thing with developers is that we tend to think like developers, and we are naturally biased towards the happy path. And QAs can be very proficient in collaborating with devs in that they will pinpoint any possible uncovered things that a user might do. So definitely, as engineers, collaborate with QAs on UI tests. It will make your UI tests much better. All right, guys, that's it for me today. And to sum up, I want you to remember the concept of executable specification. Whenever you are writing a test, make sure that you're testing your specification, you're making your specification executable. This will make your application much more robust and change much easier. Write UI tests from the perspective of your users, keep it high level, check any necessary business requirements that you want to check in UI tests. Test components for usability, that they look good in all necessary states, that all callbacks are fired with correct values. Keep your unit tests coarse, write them with purpose, and of course, go finer if necessary, but really keep them focused. Focus on that you are testing your specification of your application, and use manual testing for finding new product opportunities and creating new executable specification for your application. Thank you. If you wish to ever contact me, you can visit my website, boris.lol. There's links and you can find my email address there. Feel free to chat. Write me about anything. I'm happy to chat about stuff, be it engineering or gym or whatever. Thank you.
Awesome. Thank you so much. I don't see any questions in the comments, so we will give everyone a few more seconds to write their comments or like the questions. If they will not make it, they can like reach you. You showed the way. Billy says, thank you. Great. Great presentation. Thank you for watching, Billy. Everyone, thank you for watching. If you have a few seconds to spare, please fill out our feedback. You can find it already in the live chat. Okay, and I still don't see any questions, so be sure to reach us, to follow us on our other channels if you remember the questions later. That is all from us. Have a great evening and bye next time.